statement regarding 100% loading on overcurrent devices in residential applications is outdated. According to the 2017 National Electrical Code, or NEC, 100% loading is permissible on residential circuit breakers, but this is contingent on specific conditions and adherence to the NEC guidelines. This is a crucial update for electricians, electrical engineers, and anyone involved in residential electrical installations. Understanding the NEC requirements for circuit breaker loading is essential for ensuring electrical safety and preventing overloads that could lead to fires or equipment damage. The NEC, specifically sections 210.20 and 215.3, addresses the requirements for overcurrent protection, and it's vital to consult the latest edition of the NEC for the most up-to-date information. The NEC provides detailed instructions on how to properly size circuit breakers to protect electrical circuits from overcurrents. Overcurrent protection is designed to protect the conductors and equipment connected to the circuit. Circuit breakers are designed to interrupt the flow of electricity when the current exceeds the breaker's rating. This protects the wiring from overheating and potentially causing a fire. The NEC mandates that overcurrent protection devices must be sized to carry the load they are intended to serve without exceeding their rated capacity. The specific NEC sections you mentioned, 210.20 and 215.3, detail the requirements for branch circuits and feeders respectively. Branch circuits are the circuits that supply power directly to outlets, lighting fixtures, and appliances. Feeders are the conductors that carry power from the service equipment to the branch circuits. To determine the appropriate size of a circuit breaker, it's necessary to calculate the total load on the circuit. The total load includes both the continuous and non-continuous loads. A continuous load is defined as a load that operates for 3 hours or more at a time. Non-continuous loads are those that operate for less than 3 hours at a time. According to the NEC, the overcurrent protection device must be rated at not less than 125% of the continuous load plus 100% of the non-continuous load. This means that if a circuit has a continuous load of 10 amps and a non-continuous load of 5 amps, the circuit breaker must be rated at least 17.5 amps. Since circuit breakers are typically available in standard sizes, the next highest standard size, which would be 20 amps in this case, would be selected. It's important to note that the conductors must also be sized to carry the calculated load. The NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and installation conditions. The ampacity of the conductors must be equal to or greater than the rating of the overcurrent protection device. If the conductors are not sized properly, they could overheat and potentially cause a fire, even if the circuit breaker is sized correctly. In addition to the load calculations and conductor sizing, the NEC also specifies requirements for the installation of circuit breakers. Circuit breakers must be installed in enclosures that are suitable for the environment in which they are located. The enclosures must protect the circuit breakers from physical damage and environmental factors such as moisture and dust. Circuit breakers must also be properly labeled to indicate their amperage rating and the circuits they protect. This helps to ensure that the correct circuit breaker is used for each circuit and that electricians can easily identify the circuits during troubleshooting and maintenance. The UL listing of circuit breakers is also an important consideration. Underwriters Laboratories, or UL, is an independent organization that tests and certifies electrical products to ensure they meet safety standards. UL-listed circuit breakers have been tested and found to be safe for use in accordance with their intended application. The UL listing mark on a circuit breaker indicates that it has been evaluated and meets the applicable UL standards. These standards cover a wide range of safety requirements, including the breaker's ability to interrupt overcurrents, withstand short circuits, and operate safely under various environmental conditions. When selecting circuit breakers for residential applications, it is important to choose UL-listed breakers from reputable manufacturers. This helps to ensure that the breakers will provide reliable overcurrent protection and meet the safety requirements of the NEC. The reference to residential type molded case circuit breakers not being suitable for 100% loading is a point that requires clarification in the context of current NEC standards. While older editions of the NEC and previous UL standards may have restricted 100% loading on these types of breakers, the current standards allow for it under specific conditions. These conditions generally involve the circuit breaker being specifically listed and labeled for 100% continuous duty operation. This listing signifies that the breaker has been tested and certified to handle continuous loads equal to its ampere rating without exceeding temperature limits or compromising its safety performance. It is crucial to differentiate between circuit breakers listed for 100% loading and those that are not. Circuit breakers not specifically listed for 100% loading must still adhere to the 80% loading rule, where the continuous load should not exceed 80% of the breaker's ampere rating. This ensures a safety margin to prevent overheating and potential failures. To determine whether a circuit breaker is listed for 100% loading, refer to the manufacturer's specifications and the UL listing information on the breaker itself. The labeling should clearly indicate whether the breaker is suitable for 100% continuous duty. In summary, the 2017 NEC permits 100% loading on residential circuit breakers, provided that the breakers are specifically listed and labeled for 100% continuous duty operation. It's important to consult the latest edition of the NEC and the manufacturer's specifications to ensure compliance with all applicable requirements. A maximum loading of 80% is still a good practice for circuit breakers not listed for 100% loading or in situations where there is uncertainty about the load characteristics or breaker capabilities. This provides an additional safety margin and can help to extend the lifespan of the circuit breakers. Now let's delve deeper into the implications and practical considerations of the 100% loading rule in the NEC. Firstly, the allowance for 100% loading on circuit breakers requires a thorough understanding of the connected loads and their characteristics. It is essential to accurately calculate the continuous and non-continuous loads in the circuit to ensure that the breaker is properly sized. Secondly, the 100% loading rule should not be interpreted as a license to overload circuits. The NEC still requires that all electrical installations be designed and installed in a safe and workmanlike manner. This includes ensuring that conductors are properly sized, that connections are made correctly, and that the overall installation meets all applicable code requirements. Thirdly, the 100% loading rule should be applied with caution in situations where there is uncertainty about the load characteristics of the breaker's capabilities. In these cases, it may be prudent to adhere to the 80% loading rule to provide an additional safety margin. Fourthly, it is important to consider the ambient temperature in which the circuit breakers are installed. High ambient temperatures can reduce the ampacity of circuit breakers, so it may be necessary to derate the breakers accordingly. The NEC provides tables that specify the derating factors for circuit breakers based on ambient temperature. Fifthly, the 100% loading rule should not be applied to motor circuits without careful consideration. Motor circuits have unique characteristics that require special overcurrent protection. The NEC provides specific requirements for motor circuit protection, which must be followed to ensure safe and reliable operation. Sixthly, the 100% loading rule should be applied only to circuit breakers that are specifically designed and listed for this purpose. Using circuit breakers that are not designed for 100% loading in applications where they are subjected to continuous loads can lead to overheating, premature failure, and potentially dangerous conditions. Seventhly, it is important to regularly inspect and maintain circuit breakers to ensure that they are operating properly. Circuit breakers should be checked for signs of overheating, damage, or loose connections. Any faulty circuit breaker should be replaced immediately. Eighthly, the 100% loading rule should be applied only by qualified and experienced electricians who have a thorough understanding of the NEC and electrical safety principles. A proper application of the 100% loading rule can have serious consequences, so it is important to ensure that all electrical work is performed by competent professionals. Ninthly, the 100% loading rule is not a substitute for good electrical design practices. Electrical systems should be designed to minimize the risk of overloads and to provide adequate capacity for future growth. This includes using energy-efficient appliances and lighting fixtures, properly balancing loads, and providing sufficient spare capacity in the electrical panel. Tenthly, the 100% loading rule should be applied in conjunction with other NEC requirements, such as those for ground fault protection and surge protection. Ground fault protection is designed to protect against electrical shocks, while surge protection is designed to protect against damage from voltage surges. Both of these types of protection are important for ensuring the safety and reliability of electrical systems. In conclusion, the 2017 NEC permits 100% loading on residential circuit breakers under specific conditions. It's crucial to understand these conditions, consult the NEC, and prioritize safety in all electrical installations.